Hi everyone. In this video we're going to look at calculating some definite integrals with simple equations involved. So we haven't yet made a connection to how do we actually do this algebraically, but we can do a lot of things graphically in this section. So it specifically even guides you that direction in the problem statement. It says to use a graph to help you find the exact value of each integral. So I would first like to figure out what the graph of y equals 3x looks like on the interval 0 to 1. So I know it's a line. I'm going for y equals 3x. I know it crosses through the origin and it has a slope of 3, which means from here I'm going to go over 1, up 3, 1, 3, and whoops, very crooked. Pretend this is a straight line. This is the graph of my function. I'm only really interested in what's happening between x equals 0 and x equals 1, and that's because those are the limits of integration. So from 0 to 1, I would like to think about how much area I've captured. And all I've caught so far is this one little triangle. So it has a base of 1 and a height of 3, which means its area is half of 3 times 1, or 3 halves. Now we want to think about the fact that this is integral, not area. They're related, but not exactly the same. However, everything is above the axis in this one, so that really is my answer. The integral of y equals 3x from 0 to 1 is 1 1/2, 3 halves. So I would expect you to be able to figure this out for any linear function for sure. We would always have a triangle or a trapezoid that we were working with. Okay, so for part B, same idea, a little bit messier function. We're trying to go from -1 to 4. So let's see, if we plug in -1, we get 4. So it should go through -1, 4. And then if we plug in 4, we get 2 minus 8 is -6, comma, -6. Okay, so let's go maybe about like this. So if this is -1, and this is 4, that's the interval we're interested in. We know it goes through, let's go with this. Let's say this is 2, 4. So it goes through -1, 4. And then it's going to go through, let's see, 0, 2, and then 1, 0. It's going to keep heading down until we hit this point, which is 4, -6. And this one was -1, 4. Okay, so there's my graph. I am interested in the area that I'm catching between x equals -1 and x equals 4. So I'm catching a triangle here and a bigger triangle here. So this first triangle has a base of 2. It goes from -1 to 1, and it has a height of 4. So its area is going to be half of 2 times 4, so half of 8, which is 4. The bigger triangle has a base of 3. We're going from 1 out to 4, and a height of 6, which means 6 times 3 is 18, half of 18 is 9, so we're getting 9. Okay. So if we were asked just for the total area trapped between the function and the axis, I would say 9 plus 4 is 13. But we were asked for the definite integral, and the definite integral is going to say, okay, I'm taking little infinitely small dx's, I'm multiplying them by heights that are given by 2 minus 2x. Some of those heights are negative. So the integral is going to say I have 4 units above the axis. I need to subtract off 9 units below the axis. And 4 minus 9 is -5. So again, this contrast between area and integral is really important. Okay, last one. -1 to 1. Okay, first thing is just a recognition thing. If we're saying y is equal to 1 minus x squared, then we could say, oops, square root of, we could say that y squared is equal to 1 minus x squared, or x squared plus y squared is equal to 1, which is the equation for the unit circle. But we have to be a little careful if we're working our way back up. If we rearranged x squared plus y squared equals 1 by first subtracting x squared and then square rooting both sides, we should really have a plus or minus. And since that disappeared, sorry, you're getting kindergarten writing on my tablet today, question mark. That means we've actually lost part of the circle. Since it was a positive or negative y we were looking at, what we've lost, see y values, not why, actual y values. We've lost all the negative y values. So this is the top half of the unit circle. It's a little crooked, pretend it's round. Okay, and we want everything from -1 to 1, so we want this entire top half of the unit circle. The area of the unit circle would be pi times 1 squared. Since it's only the top half, we'll throw a 1/2 out in front, which means that we're getting, here, do a color, we're getting a pi over 2, a 1/2 pi. Okay, so basically, if I give you the equation for a line or some part of a circle, I would expect you to be able to draw a graph and figure out how much area is trapped between that and the x-axis. Thanks for watching.